We got started in 1980, brewed our first batch of beer at a smaller facility. I was a home brewer who turned commercial brewer. Got 450 employees, 7th or 8th largest breweries in the country. Distribution in every state. I wanted to be more energy independent, and so we started looking at ways to both conserve energy and be more energy efficient. Actually, going back to when we first started, I put in things like ice banks to store energy at night, and so we've been embracing some of those concepts for a long time. We've done a lot of optimization and put in current technology, and some of those projects have 2 or 3 year payback, so it's not all done strictly for environmental benefit, but it's nice to get both. Some of the projects don't have great returns, and so you really couldn't justify them strictly on a return on investment basis. And we do a lot of what we do because we think it's the right thing, and as a manufacturer, being in an industry that does utilize a lot of resources, we see it as one of our obligations to do our business in a sound manner and look for ways to minimize inputs and to minimize waste streams. As a manufacturer, power needs are 24/7 because we have refrigeration and pumps and things that are operating. It was both from energy efficiency and from air emissions, I guess, that I really wanted to give the fuel cell a try. We've got 4 250 kilowatt units that are considered a direct fuel cell, so they don't need a separate source of hydrogen. They have an internal process that reforms the hydrogen out of the feed gas. So we feed it either biogas or natural gas, and the process is part of the fuel cell stack. And so as the gas goes in, the hydrogen gets separated, and then that's fed into the fuel cell. We also have heat recovery boilers. We capture about 1.25 million BTUs of energy back as steam, and that goes back into our brewing process. The fuel cell is, I think, at the top as far as overall conversion of that input energy to output electricity. Having the distributed power generation, you're not losing power through transmission line loss. If you can co-generate and use the heat and the electricity, you've picked up even more. So I think our overall efficiency is approaching 70% for our input energy with the heat recovery, which would be close to double, I think, what the average fossil fuel plant would be putting out. As far as nitrogen oxides and sulfur dioxide and other things that are normal combustion byproducts, none of those that are emitted from the fuel cell. All of our fermenters are tied into pipes where we can collect the carbon dioxide that's naturally produced from fermentation, and that's compressed and cleaned up and stored and allows us to have our own source of CO2 here. Normally, breweries would purchase that if they don't recover it, and so now that we've recovered ours, we have our own source of naturally produced carbon dioxide that's been captured rather than emitted. Naturally produced carbon dioxide. It's used in the bottling process and moving beer around and dispensing beer. So we've just completed a pretty big solar array. I think we'll have one of the largest in the country. So that's pretty exciting, and we're using sort of new inverter technology that's very efficient. So we're doing a good job converting sun's energy into electricity. Middle part of the day, we're drawing more power. So when our solar panels are putting out their maximum is when our power consumption is at its maximum as well. When the solar's not working, we have our fuel cells giving us our base load. So it's a good combination for us. Actually have our own herd of cattle. We feed our spent grain to the cattle, and the manure from that is composted and put back on our hops field. So we have a fairly closed loop on our hops here on site. We do treat all of our own wastewater. So we take all of our waste streams, our liquid waste from the brewing process, spilled beer, yeast, bits of hops and malt, and that's fed into a digester which produces between 35 to 70 cubic feet a minute of methane. And then that methane is fed to the fuel cells. We use a mix of biogas and natural gas. Since this is more efficient, it'll be cheaper to produce power this way. Up to close to 80% of our own electrical power needs generated here on site. Our goal will be to get to 100% power generation, and through both conservation efforts and some additional power generation, I think we can get there. I think it works for a lot of other industries. We get a lot of visitors here. I know there's quite a few hotels in one group that's put in fuel cells. One of the local casinos has put them in. So if you have a need for both heat and electricity on a continuous basis, you can justify this kind of technology.
Funding provided by the U.S. Department of Energy's National Energy Technology Laboratory, the Energy and Environmental Research Center's National Center for Hydrogen Technology, and the members of Prairie Public.